Okay, in this particular example, we are being asked to write a polynomial function in standard form with the given zeros of -2, 2, and 3. So when we start off doing that, first of all, I need to make sure I write y equals so that I actually have a function and not just an expression. Sometimes people leave that off, being technical and paying attention to the vocabulary there. So I have a polynomial function, and I want it to have these given zeros. Well, if it's going to have these given zeros, then it will have the linear factors of x minus each one of these numbers. So it would have x minus -2, x minus 2, and x minus 3, like that. So again, it's always x minus then each one of these real zeros. Now, I can clean that up a little bit because I wouldn't want to say x minus -2. Right there, subtracting a negative is the same thing as adding. So we have x plus 2, x minus 2, and x minus 3 for that. Now, if the directions had just said write a polynomial function with these given zeros, we've done that. But since it says write a polynomial function in standard form, we need to go ahead and multiply this out. And it doesn't really matter which two binomials you choose to multiply together first. You have to do two of them, and that'll create the product, and then you need to multiply that product by the other binomial. I'll do that a couple different ways just to verify that for you. So let's say I wanted to start off multiplying these two binomials together, as I think that's the easiest way to go about doing this problem, because I recognize this as the factored form of a difference of squares, so some things will cancel out when we try to do this multiplication. Starting off, we take x times x, which will make x squared. And then when we take this x times this -2 here, we get -2x. And then when we just start distributing here, we get +2x. So this multiplication of these outer things and these inner things actually cancel each other out, making +2x and -2x. So then finally, I would just need to multiply +2 times -2, which would be -4. Then bring down this other binomial, and now we need to multiply this out. It's not going to cancel out here. So as we do that, x squared times x makes x cubed. X squared times -3 makes -3x squared. Then continuing to distribute, -4 times x makes -4x. And -4 times -3 makes +12. I don't have any like terms to combine there, and as I take a look at that, I can see that it is, in fact, written in standard form. My terms go from highest degree to lowest degree right down through. So there's the standard form of that. I'm going to go ahead and show you that you could have multiplied that out a different way and ended up with the same thing. So you kind of have your choice of how to go about that. So let's say you wanted to multiply these two binomials together first. You certainly can. So I'm going to go ahead and bring down this first binomial then of x plus 2. And now multiplying this together over here, x times x makes x squared. X times -3 makes -3x. -2 times x makes another -2x. -3x and -2x makes a total of -5x. Again, I just did those two steps and combined like terms all in one. That gave me -3x there. That gave me -2x there. That's a total of -5x. And then finally, -2 times -3 is +6. If I continue distributing, now I have to multiply this binomial times this trinomial. I have x times x squared, which makes x cubed. I have x times -5x, which makes -5x squared. X times 6, which makes +6x. And then I still need to distribute this 2 to all three of those things. 2 times x squared makes 2x squared. 2 times -5x makes -10x. And 2 times 6 makes 12. Combining some like terms. -5x squared plus 2x squared, that should leave me with -3x squared. I have a +6x and a -10x, which should leave me with a -4x. And then finally, I have the plus 12 at the end. And you should see I arrived at the same thing, at least I hope that's the same thing, unless I made a mistake somewhere, as I had when I multiplied that out the first way. So, of course, there's always going to be the person that says, well, I can do it a different way. Well, certainly you could. The directions here just said write a polynomial function in standard form with those given zeros. Somebody else could add a different zero to it. It didn't say just with these zeros. It didn't say with least degree. I don't want to overcomplicate things. But this polynomial function is about the simplest you can come up with that meets the conditions. Of course, if you wanted to be an overachiever, there's definitely some other ways you could come up with other functions that would have these zeros that would look different. But that's up to you. We can have that conversation later if you'd like.